This presentation is about the plasma substitutes. Syllabus includes need of plasma expanders or plasma substitutes, then desired properties of plasma substitutes, then three examples, that is hydrolyzed gelatin based product, Hetastarch and Dextran. So source, preparation and official injections of all three examples are included in the syllabus. In the earlier chapter, we have studied about the blood substitutes. So blood substitutes are also called as artificial blood or blood surrogates. They are the substances which are used to mimic and fulfill some functions of biological blood, usually in the oxygen carrying cells. Now, this topic is about the plasma substitutes. Now, before that, we'll just define or revise what is plasma. So, blood plasma is a yellowish liquid component of blood that holds the blood cells in the whole blood in the suspension. So, it is the liquid part of the blood that carries cell and proteins throughout the body. So, it contributes to about 55% of the total blood volume. So, what is the use of blood plasma uh, substitute? Plasma substitute. So, it is used in the treatment of circulatory shock. It is used to restore the vascular volume, to stabilize the circulatory hemodynamics, and to maintain the tissue perfusion. Now, plasma expanders, in short, are used to restore the circulating volume of a hypovolemic patient. That means whenever there is a loss of blood and we want to maintain the hemodynamics of that person, and in that case we give him plasma substitute. Now this plasma expanders, they have a relatively high molecular weight and they boost the plasma volume by increasing the osmotic pressure. As described earlier, they are used in patients who have suffered from hemorrhage or shock. Now what do? They increase the osmotic pressure in the intravascular space. So whenever you inject this plasma expander, water moves from the interstitial spaces into the intravascular space and they thereby increase the circulating blood volume, which is what is required in case of blood loss. So these are the ideal properties of a plasma expander or plasma substitute. One is they should have the same colloidal osmotic pressure as that of the whole blood. The viscosity should be similar to that of plasma. The molecular weight of the product should be such that the molecules do not easily diffuse through the capillary walls. They should be maintained inside the capillaries. They should have fairly low rate of excretion or destruction by the body. Eventually should have complete elimination from the body. They should be non-toxic, as in they should not impair the renal function of the body. They should be free from antigens, pyrogens, and they should not confuse the test results of blood grouping and ESR. They should not interfere with this test. They should be isotonic. They should be highly stable. Also stable during the sterilization temperature and during the transit period, that is the transport and the storage. They should have ease of preparation, readily available and low cost. So there are two types of expanders. One is crystalloids. They are the aqueous solution of mineral salts or water-soluble molecules. The examples are the normal saline, dextrose, and the Ringer solution. The second type is colloids. They are larger insoluble molecules. Examples are dextran, albumin, gelatin. Now, there are some advantages of colloids over crystalloids. The larger molecules of colloids are retained more easily in the intravascular space, and they increase the osmotic pressure, which is desired in case of uh, hypovolemic patient. More effective uh, plasma volume restoration occurs by colloids than by the crystalloids. Also, the duration of action is relatively longer than crystalloids. First is an example is a dextran. Dextran is a polysaccharide. Now it is obtained by the process of similar to fermentation, wherein sucrose is used as a medium, and the organism which is used to convert this sucrose into dextran is the lactic acid bacteria from the family Lactobacillus. The species includes Leuconostoc mesenteroids and Streptococcus mutans. Now, whatever is the dextran obtained, the type and the structure, it depends upon not only on the family and the species of the bacterium, but the strain of the bacteria used. Next point shows the reaction which occurs in sucrose from the medium gets converted into dextran and fructose. So what happens is this microorganisms, it secretes an enzyme called dextran sucrase, which converts this sucrose into dextran and fructose. So dextran obtained can be precipitated out and further purified by various means. Now there are two main groups of dextran which is produced. One is the long and practically unbranched chain of glucose units joined by 1,6 glucosidic linkage, and second is the highly branched polymeric which consists of short chains of 1,6 units joined by 1,4 and 1,3 linkage to branches. If the product is a branching dextran, and if it is used as an plasma substitute, it will give rise to allergic reaction. Uh, the most of the dextrans which are used as a plasma substitute should have a linkage of 1,6 type, and this type of linkage can be specially achieved by specially developing a strain of organism which will produce 95% of 1,6 linkage. Next is about the production of dextran. The method is similar to the production of antibiotics, uh, that is fermentation. Here, the organism is inoculated in the medium in the seed tank, and then it is transferred to the fermenters, which are having capacity of about 4,500 cubic dm. Uh, Aseptic conditions are not required because conversion of sucrose into dextran in presence of enzyme is very rapid. Also, the need for sterile air, that is supply of sterile air, is not required. If at all this is done, then the process is inhibited. One important thing is that we generally sterilize the culture medium before introducing the organism, and there are chances that during the sterilization the sucrose the present in the medium may get hydrolyzed into glucose and fructose, and if this occurs, dextran will not be formed, because dextran is not a product of inversion, but it is a product of transglycosidation of sucrose. In short, what we need is sucrose, not glucose and fructose, for production of dextran. Now, this can be prevented by adjustment of media to neutral pH before sterilization and avoiding overheating. Now, when after the fermentation, when maximum conversion to dextran is obtained, Then the dextran is precipitated by treating it with suitable organic solvent. Generally, it is methanol. Now, dextran it consists of approximately 2 lakhs glucose units with molecular weight of 50 millions. Now, if at all there are very large molecules of dextran whose molecular weight is above 2,50,000, they have serious drawbacks. So what are the drawbacks? First is they are very viscous, so they will be very difficult to administer. They can cause renal damage and allergic reaction. They also interfere with the blood matching and sedimentation test by causing Rolex formation. Rolex formation is nothing but aggregates of red cells that resembles the piles of plates, and they produce colloidal osmotic pressure which is lower than that of smaller molecules. Question may be asked in this what are the disadvantages of dextran which has molecular weight above 2000 2 lakhs 50,000. So this are the four reasons why we cannot have dextrans with high molecular weight. To produce a material of suitable molecular weight, there are some methods. The first method is the acid hydrolysis, in which the dextran is adjusted to pH 2 and is heated at 90 degrees Celsius. So, as the hydrolysis proceeds, the preparation becomes less viscous and the reaction can be stopped at the required viscosity. Second method is by the thermal degradation, wherein the solution of dextran is heated under pressure at 160 degrees Celsius in the presence of sodium sulfite. Now, sodium sulfite is used to prevent oxidative deterioration, and second is the presence of calcium carbonate, which helps in neutralizing the acidity. The method is slower than acid hydrolysis, but whatever is the yield is of the preferred molecule, and with a fewer reducing group, that is the fructose. Uh, Ultrasonic disintegration, this is done by bombarding with ultrasonic waves which splits the molecule into the desired size. Now this method is very expensive. Out of these three methods, uh, acid hydrolysis is the most preferred method for obtaining the dextran of desired molecular size. Next method is seeding the fermenter, wherein during the fermentation process itself, low molecular weight dextran is added, which is used as a template by the organism to produce the further dextran molecules. This is called as the seed, over which the further production of dextran takes place. As I said earlier, acid hydrolysis is the most commonly used method for getting the desired molecular weight dextran, and with this process, we get dextran molecules in the range of 10,000 to 1 million in molecular weight. Now, as high molecular weight dextran has some disadvantages, small molecular weight dextran, that is the dextran whose molecular weight is about 60,000 or low, also has some disadvantage. They are rapidly excreted in the urine and they pass into the tissue fluids, causing adverse osmotic pressure. So we need dextran in the range of 60,000 and 2 lakhs 50,000. So this is a summary of what we discussed earlier. So below 60,000, they are rapidly excreted in urine and they are lost in tissue. And above 2,50,000, they cause allergy, renal damage, and they interfere with the sedimentation test. Now what we need is in the range of 60,000 and 2,50,000. In that also, the acceptable range is 1 lakh to 2,50,000. This slide shows the American type dextran and the British dextran with their properties, and this is just for your information. So even after a selected fraction is obtained, purification is required. There are some impurities which has to be removed. The first impurity is the reducing sugar. That is nothing but a byproduct of the conversion. So this is removed by solvent precipitation. Second is by the solvents. The whatever solvents are reduced for precipitation are removed by evaporation under reduced pressure. Next is the inorganic solvents, which are removed by demineralization in a mixed ion bed exchanger. It is important to remove phosphate as they may cause precipitation during the final sterilization and storage. Color may be present. It is removed by adsorption onto activated charcoal. Pyrogens and microorganisms can be present. The pyrogens are removed by adsorption on the asbestos or cellulose derivative, and microorganism is generally removed by membrane filtration. After removal of the impurities, the solution is diluted to 5% in either 5% dextrose injection or NaCl injection, and it is packed in sulfur treated soda lime bottles and closed with lacquered rubber plugs. These are further subjected to sterilization in autoclave at 115 degrees Celsius. All QC tests which are applicable to parenterals are applicable to Dextran. Some chemical tests are also required. That is, we need to check the presence of lead, acetone, and alcohol, reducing sugar, nitrogen, and any other acid or alkali. Biological test will include the pyrogen test, that is injecting the product in healthy rabbits and checking for any pyrexia. Then dextran content can be determined by using polarimeter. The next part is about the official preparations of dextran. There are three official preparations of dextran. One is dextran 40, dextran 70, and dextran 110. The numbers they indicates the molecular weight. The method of preparation and the QC test are same as we discussed in the earlier slides. This is just for your information. Go through it. Now, the method of preparation for this remains the same. That is what we have discussed in the introduction of Dextran. Now, this is from the IP. So what you see is the marketed name of Dextran injection, that is Gentran 40 and Rio Macrodex. So if you see, the molecular weight is mentioned, and the microorganism which is used is mentioned. Again, in the second point, the type of linkage is mentioned, that is alpha 16, and then uh, the specification, that is it should not contain less than 9% and not more than 11% weight by volume of dextran, along with the description. The storage condition includes that it should be stored at temperature not exceeding 30 degrees Celsius and should not be exposed to fluctuation in temperature. And the labeling directions are also mentioned, that is it should mention the strength as in the percent weight by volume of dextran, the name of the solvent, whether it is dextrose or sodium chloride, the strain of the microorganism used, and with one instruction that if the preparation is found to be cloudy or if it shows the presence of deposit, it should be discarded. Next example of plasma substitute is hydroxyethyl starch, also called as Hetastarch. It is a complex mixture of ethoxylated amylopectin of various molecular size, and the average molecular weight is about 4.5 lakhs. It maintains the blood volume for a longer duration of time. It does not cause renal failure or coagulation disturbances, and it improves the hemodynamic status for 24 hours. So, hydroxyethyl starch is a synthetic colloid. Now, what is mentioned in your syllables is the preparation or source. So, this is what you have to write, that it is a modified branch in glucose polymer derived from amylopectin sources such as potatoes, sorghum, or maize. Now, from this starch preparation, what you get is tetrastarch, hetastarch, and pentastarch. Now, hetastarch, pentastarch, and tetrastarch has its own property. So these 3 points, that is about the heta, penta, and tetra, should not be included. This is just for your information. Now we are concerned with hetastarch. So hetastarch has most molecular substitution, and they remain for a longer period of time in the vasculature, and there are the clearance time is also slow, so uh, it will remain in the body for a longer duration of time. Now, although hetastarch is prevented from hydrolysis in the blood, they thereby produce a longer duration of action. But this property of remaining inside in the intravascular space is also associated with accumulation in the reticuloendothelial system, skin, liver, and kidney. So hetastarch, they remain accumulated in all these four things. So I got one formulation of hetastarch. So 6% hetastarch in 0.9% NaCl injection. This is the composition. Hetastarch is 6 grams, NaCl is 0.9 grams. Water for injection, quantity sufficient, and the pH is adjusted with sodium hydroxide if necessary. Now this pH will be according to the blood. uh, Concentration of electrolytes is mentioned, that is sodium should be 154 milliequivalent per liter, and same for chloride. The pH should be 5.5, and the osmolarity should be approximately 309 milliosmol. Next is the marketed hydroxyethyl starch preparations. So two examples I've got which are marketed under the name of Hespan and Hextend. Both are 6% hetastarch in 0.9% sodium chloride injection. The plasma volume expansion which is produced by this hetastarch is approximately that of 5% of albumin, that is a normal albumin which is present in the blood. This intravenous infusion of hetastarch injection, they results in expansion of the volume that decreases over 24 to 36 hours, so you can maintain the plasma volume for 1 day. Then next is the degree of plasma volume expansion and the improvement in the hemodynamic state will depend upon the patient's intravascular status. Hetastarch molecules which are below 50,000 molecular weight are rapidly eliminated by renal excretion, and the addition of this hetastarch to whole blood will increase the ESR or erythrocyte sedimentation rate, and hence these injections are used to improve the efficiency of granulocyte collection by centrifugal means. Hetastarch is used in case of hypovolemia. Next is it is used as an adjuvant in leukapheresis, and it does not cause coagulation abnormalities as that of Dextran, and nor it interferes with the cross matching of the blood. Now coming to the benefits and the disadvantage of hydroxyethyl starches. So benefit is they have a very good plateau effect which last for about 4 hours. Then they can be easily broken down by the amylase, an enzyme which is present in the plasma. Disadvantage is that they may sometimes cause severe irritation, and they may interfere with the serum amylase level. Next example of plasma substitute is gelatin. So gelatin is a large molecular weight protein which is formed from hydrolysis of collagen. Now this has an advantage of significant oncotic effect when it is injected, but has a disadvantage that they have high viscosity, and gelatin has a tendency to change from tendency to gel or solidify when it is stored at low temperature. So you cannot maintain the liquid consistency of the gelatin. Next is we can modify this gelatin, and these modified gelatins are collectively called as new generation gelatins. So there are three types. One is succinylated or modified fluid gelatin. These are the brand names or the marketed names of the gelatin, that is gelofuscin, plasma gel, and plasminol. Then you have urea cross-linked gelatin. Example is polygelatin. And third is oxypolygelatins, that is jelifindol. So polygelatin is produced by the action of alkali and then boiling, that causes the thermal degradation on collagen from the cattle bones. Next is the resultant polypeptides is of the molecular weight of 12,000 to 15,000, and these are urea cross-linked using hexamethyl diisonate. The branching they lowers the gel melting point, and in this case the molecular weight ranged from about 5,000 to 50,000. The average is 35,000. So I found two marketed preparations of gelatin. One is named by Hemacell. So if you see, it contains polygelatin, that is polypeptides of degraded gelatin, which is cross-linked via urea, and the other components are NaCl, KCl, calcium chloride, and water for injection. Again, the electrolyte content is mentioned. Next, we have EcoFlac, that has modified fluid gelatin. The molecular weights are mentioned. The other constituents are sodium chloride, sodium hydroxide, and water for injection. Again, the electrolyte levels are mentioned. So from the label, you must have observed that the formulation does not have any preservative, and the molecular weight is between 30,000 to 35,000. So this causes rapid excretion from the body via urine and complete plasma clearance. That is, this will be retained for max 3 days, after which it is completely excreted from the body. Up to 50% is removed within first 4 to 8 hours following administration, and only 1% is metabolized. No storage within the reticuloendothelial system, and they claim to have no effects on the coagulation